Welcome to this latest video of the EU-funded project UrbanFlood. My name is Jeroen Broekhuizen and I'm Technical Manager of the UrbanFlood project. What you see here is the latest result from 3 years hard work between the partners of the UrbanFlood project. Wallingford from England, STOWA from the Netherlands, TNO from the Netherlands, Siemens from Germany and Russia, and Cifronet from Poland. We all work together to create an early warning system for flood defenses. And not just a single early warning system for a single flood defense, no, an infrastructure that's using cloud technology to enable multiple flood defenses and multiple early warning systems at the same time. And we're using the data together from all these parties to create this system and learn from it. In UrbanFlood, we're looking at creating an online early warning system for flood defenses. And online is real time, so it's always looking at the data. And early warning system is protecting us against the water. Look at the Netherlands here, for example, and England, which are two countries heavily affected by the sea, by rain, and by the rivers. In the Netherlands, 80% of the economic value is below sea level. And we need to protect this. And how do we do this? We look at all the flood defenses protecting us against floods, rain, or rivers, and we watch them in real time through the internet. And each icon you see here on the screen is one of those locations where we're looking at the data. But imagine that we only have like 20 or 25 locations that we're monitoring right now, but the Netherlands has over 20,000 kilometers worth of flood defenses. How can we watch all of this at the same time? How can we manage this? That's what UrbanFlood is tackling. That's what we do in this project. What we're doing is creating an online early warning system. So it runs in the cloud. It uses cloud technology to facilitate all these objects that we're monitoring. So instead of having one computer per flood defense, for example, we can now have thousands of computers all looking at the same data. And we can scale this up not just for the Netherlands or England, but even further, looking at, for example, Europe or even worldwide, where we have some monitoring in China or here in the United States, all through the internet and using the cloud technologies. What we created in UrbanFlood is a framework to make this happen. So it's not just we connect a new flood defense to the system and have to make all kinds of programs and push magic buttons. No, we can just copy-paste the workflow for a different flood defense and we have a new system up and running, just like that. Let me zoom in back to Europe here. And let's go to this location here in England, where I can show you an example of what this early warning system looks like. And let's zoom in by touching the icon. And then we are in the Boston City area, where here's the city center, and here's the river. And on each side of the river, there's a flood defense in place to protect the city from flooding. And these green areas represent the parts of the flood defense where we have sensors inside. So let me just touch this middle one, and as you can see here, now we're suddenly looking inside the flood defense. So this is the flood defense, and you see some sizes and also the locations where the sensors are located. And these sensors, they measure all kinds of things, so temperature, displacement, and pore pressure especially. And pore pressure is the amount of water above the sensor. And let me just show you the actual site so you can see what's going on. So this is the location when it's high tide, and here's the location when there's low tide. And you can see there's a big difference in the amount of water in the river. And that's because the tide difference is about 6 meters, which is really high. And inside this section of the embankments is where we put the sensors in. So let's switch the sensors now. Let me put this to the side and go to the sensors. And I can open up, for example, this one, which is measuring the amount of water. And so we'll be able to see the tides. And as you see here, it's going up and down because the amount of water is going up and down in the river. And so it's showing the same thing here in the sensor data. And what we're looking into is, can we predict, can we learn the normal response of the flood defense to the tides going up and down. And so, for example, if the tide goes up, the sensor value should also go up. And if the tide goes down, sensor value should also go down again. But what if the tide goes up, but the sensor value doesn't go up? Or if the tide goes down, the sensor value doesn't go down? Then we want to create an alert. Something strange is happening. And if something strange is happening, we can look at the data and see what's going on. For example, is it raining? So maybe even though the tide is going down, the dike, the flood defense is still wet from the rain. And since this system is based on the internet and on cloud technology, experts from all around the world can look at the same data at the same time. So experts from New York, from England, from Holland can all look at the same data and correlate with each other, and they can talk with each other to understand what's going on. And if they know, then they can flag it and say, oh, everything was normal, everything is okay. And what we did here is use the expert knowledge from these 3 countries combined to come up with a model that predicts if this flood defense is actually okay or not okay. And for this we have a probability of failure calculation. And let me open it up like this. And this is for the same time frame. So here it is, graph. It's for the same time frame where we saw the tide going in and coming out again. And we can see the same tides influencing the chance of failure of this embankment. And when you look at the values for this probability of failure, it's actually very low. So it's a 1 in 1,000 years to 1 in 500 year chance that this embankment will fail, which is up to standard for this section. And if we've calculated what's going on, we can color the sections. So as you see from the start, they are green, and that means that everything here is okay. If something was not okay, they would become yellow or even red in case of an emergency. And based on data coming from rain radar or the predicted tide levels, we can predict if the embankment will stay safe in the next coming hours or if something will happen. If something happens though, we want to be able to calculate the affected area. And for this we have a flooding simulation. Let's take a look. So here I'm going to Boston again, to the same area we were before, and now I'm going to see if there's what happens if the flood defense fails. So we're going to do a kind of flooding simulation, and I'm going to open up this one, and let's see what happens if I create a small kind of failure there. So you can see a kind of blue area coming up when there's flooding water coming into the area, and it's actually based on data like this, which is the height data for the area. So this is all the height information for this section of Boston. And let's hide this again, and let's see what happens a couple of hours after the first flooding occurs. So as you can see, this section of the town will be completely flooded. And if I go even further in time, you can see it becoming even larger. So the flood defense is really important, protecting this part of the city. And but what happens if you want to evacuate all these people, or if we want to warn them? We got a warning from the early warning system, so we know something is going to happen. We can do this calculation to calculate the affected area, and now we can see if we can send these people somewhere safe especially. So let's make this the area that's flooded, and we want to create a kind of safety area, which is, for example, here. And how are we going to direct the people there? Well, we can use this tool to see how we can go from A to B. So let me pick this one up and this one. And you see it's about 2 kilometers and it takes about 5 minutes to drive. But that's only the case if no one's on the road. If everyone's on the same road at the same time, then it will take a lot longer. And police enforcement will know this. We can share this information with the police officers in the field so they can have the same view of the data. And then they can act on it. And, for example, plan roadblocks or plan city traffic management to be able to direct the people in the right direction. Another feature of the Urban Flood project is synchronizing multiple control centers. So let's imagine something is happening here in the area, not just in Boston, but in the entire part of England. And we have several control centers that want to collaborate with each other. For example, London, Boston, Nottingham, they can all share the same information, the same view, let's say. But also, if something is happening and they want outside expertise, for example, people from the US to look at the same thing that they're looking into and discuss things with each other, that's also possible. And to do this, I'm just going to grab my second installment of the same application running on a tablet. So here we have the same kind of application running, and we can synchronize the two. And there are several ways how we can do this. One is, for example, here I can watch what the other screen is doing. So you can get a second, an update each second with the screen of this one, of my tablet. So if I move this around, you'll see that one also moving around. And so if I zoom in on my tablet to the Boston location, now you'll see it being zoomed in there as well. So you can see and share graphs or cross-sections or map areas and share the data in a way share this data in such a way that you can collaborate and see the same sensor data at the same time. Another possibility is to follow the map of the other application. So if I move around this map here on my tablet, you'll see it now relocating to the same area on my main screen here. And there's a third one creating a Skype call, so I can do actual video conferencing between the two sites, between, for example, my tablet and the crisis center running the big screen. So let's go back to the world view again and see what further we can do with the system. We saw already the sensor data and the look and feel of the flood defense and soil layers, but we also want some external data. And I have a couple of very simple but very helpful examples. Let me open up this and add some content. As you see here, there's all different kinds of information available, for example, Twitter layers, earthquakes, which we don't have much in Europe, or some flight trackers. I'm going to focus here on the rain radar. I'm going to add that one. And also the KNMI data, which is the weather data for the Netherlands. So I'm going to add those two. And you see them popping up immediately. And there's another one called the AHN, which is the height map from the Netherlands. So I'm going to activate that one too. So now you can see rain radar, weather data, and the height data from the Netherlands all at the same time. And what I can do is I can go through time, and you can see some rain coming across the Netherlands. And if I zoom out a little bit more, you can see that's even more important there in England, where the rain is actually going through England if I go through time here.